Hi all, today we are going to study about the balance activities. We are starting from activity 1.9. Yesterday we have discussed a little bit of this activity. Let's start this activity. So in this activity, what we are doing, let's read that activity in textbook. It's an example of displacement reaction, that is activity 1.9. Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked A and B. In each test tube, take about 10 ml copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. Keep one iron nail aside for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color of copper sulfate solution in test tubes A and B. Also compare the color of the iron nails dipped in the copper sulfate solution with the one kept aside. So what we are doing here? Aim of the activity is to study the displacement reaction between iron and copper sulfate. Materials required are iron nails, copper sulfate solution, 2 test tubes and thread. What is the procedure? Take 2 test tubes A and B with copper sulfate solution. We are taking 2 test tubes with copper sulfate solution. Clean iron nails using sandpaper. We are taking 3 iron nails and we are cleaning it with a sandpaper. Tie iron nails with a thread and immerse them in test tube B. Tie the 2 iron nails with a thread and immerse them in test tube B. Leave it for 20 minutes. Compare both test tubes. What is the observation? Blue color of solution fades and forms a light green solution. Iron nail gets a brown coating due to copper. What is the chemical equation occurring here? Fe plus CuSO4 gives FeSO4 plus Cu. Here Fe is solid and copper sulfate is aqueous, and this FeSO4 is aqueous and copper is solid. Scientific explanation. Iron is more reactive than copper. It displaces copper from copper sulfate solution. Copper is deposited on the iron nail. Brown coating. The solution becomes green due to formation of iron sulfate, FeSO4. Conclusion. Iron displaces copper from its compound, showing displacement reaction. So what happens in this reaction? What is in the test tube? Test tube contains copper sulfate solution. We are dipping iron to it. Iron to one test tube. Then what happens is that iron is more reactive than copper. So iron reacts with the copper sulfate, displacing copper from copper sulfate and produces iron sulfate. That is FeSO4 is formed and copper get displaced from that, and the color of this FeSO4 is light greenish and copper is brown. So what happens? We have 2 test tubes, test tube A and test tube B. In test tube A there is copper sulfate solution. What is the color of the copper sulfate solution? Yes, that's blue. And what is the color of the copper sulfate solution in test tube B? It is also blue. But when iron gets displaced, iron is immersed in this solution. What happens is that reaction happens and iron displaces copper sulfate solution. So the color of the copper sulfate is blue. But what happens when FeSO4 is formed? That blue color gets displaced and a light green color is formed because FeSO4, the color of the FeSO4 ferrous sulfate is slight greenish. So the light blue color or the dark blue color of the copper sulfate solution in test tube B diminishes and a light green solution of FeSO4 is formed. And what happens to the iron nails? Iron nails get a brown coating due to the formation of copper. This copper is formed in so this copper has brown color and it gets associated with the iron nail, and iron nail also form, or we can see a brown coating of this copper in the iron nails. So what are the two things happening here? The solution in which the iron nails were placed uh, will change color from dark blue color to light green color due to the formation of FeSO4. And for the second change, what is happening? The iron nails get a brown coating due to the formation of copper. Conclusion: iron displaces copper from its compound, showing a displacement reaction. Type of reaction is displacement reaction due to or based on the reactivity series. Here we can see an image: blue copper sulfate solution, and when iron is dipped in it, green iron sulfate solution is formed, and the color of the nails become brown due to the formation of copper metal or iron. Okay, it is very easy to understand from this figure. Draw two test tubes, blue solutions, iron nail and B. If you are drawing a figure for the exam, then we have to mark this all. That is iron nail, blue color copper sulfate solution, green iron sulfate solution, copper metal or iron, etc. Board exam perfect answer. An iron nail is dipped in copper sulfate solution. After some time, the color fades and a brown coating appears on the nail due to deposition of copper. Equation is Fe plus CuSO4 gives FeSO4 plus Cu. This is a displacement reaction. Keywords for full marks: displacement, reactivity, copper deposition, color change, iron sulfate, etc. Common mistakes to avoid is writing reverse reaction. But always remember that iron reacts with the copper sulfate solution, forming iron sulfate or FeSO4 plus copper. Never reverse the reaction. Forgetting color change. What all are the color change occurring in this reaction? I want the answer in the comment box. First color change, what happens to the solution? Dark blue color solution converts to light greenish color due to formation of FeSO4. And what happens to the iron nails? Iron nails gets a brown coating due to the formation of copper. Why does blue color fade? Due to formation of iron sulfates. Why does iron nail turn brown? Due to the deposition of copper. Identify the reaction type. It is an example for displacement reaction because iron displaces copper from copper sulfate solution due to high reactivity of iron as compared to copper. Quick revision box. Blue converted into green. Brown coating of copper is formed. Iron replaces copper. Type of reaction is displacement reaction. Okay. So this activity is finished and we can go to the next activity, that is activity 1.10. What is the activity? Okay, the activity is take about 3 ml of sodium sulfate solution in a test tube. In another test tube, take about 3 ml of barium chloride solution. Mix the two solution. What do you observe? Okay, this reaction comes under the heading of double displacement reaction. We have studied 1.9 activity displacement reaction. In 1.10 we are studying about double displacement reaction, and when two solutions are mixed, they exchange ions and form an insoluble solid precipitate. Simple equation is solution plus solution gives solid precipitate. That's all, nothing to study, we can say later. To observe a double displacement reaction and formation of precipitate, materials required are sodium sulfate, that is Na2SO4, and barium chloride, BaCl2, and two test tubes are needed. What is the procedure? Take sodium sulfate solution in a test tube, take barium chloride solution in another test tube, mix both solution, observe the reaction. What is the observation? A white insoluble precipitate is formed. The precipitate is barium sulfate. So what happens when Na2SO4 get reacted with barium chloride? A precipitate of barium sulfate is formed. Here we can see the precipitate, and this BaSO4 is the precipitate that is formed plus 2 NaCl. And the formed BaSO4 is white in color and it is insoluble and it is a precipitate. And the reaction is an example for double displacement reaction because here SO4 is displaced by chlorine and Cl2 is displaced by SO4. So two or double displacement occurs, and this is an example for double displacement reaction. Scientific explanation: the ions exchange between reactants. Na plus combines with Cl minus gives NaCl. Ba2 plus combines with SO4 2 minus gives BaSO4. Barium sulfate is insoluble, so it forms a precipitate. This type of reaction is called a double displacement reaction. Mixing two solutions leads to formation of an insoluble precipitate due to ion exchange. Type of reaction or concept is double displacement reaction, and it is an example for a precipitation reaction. And colorful diagram, we can see sodium sulfate solution, and here we can see barium chloride solution, and it's a beaker, and the formation of sodium chloride and a barium sulfate is formed. The barium sulfate is white precipitate. So this barium sulfate or BaSO4 is white in color, and it is insoluble, and it is a precipitation. So it is an example for both double displacement reaction and precipitation reaction. Two test tube solution, mixing arrow, white precipitate forming, label BaSO4. Board exam perfect answer. Sodium sulfate solution is mixed with the barium chloride solution. A white insoluble precipitate of barium sulfate is formed. Na2SO4 plus BlCl2 gives BaSO4 plus 2NaCl. This is a double displacement and precipitation reaction. Keywords for full marks: precipitate, double displacement, ion exchange, insoluble, barium sulfate. Common mistakes to avoid: writing soluble product, forgetting the precipitate symbol, and not mentioning double displacement. Okay, we can see a downside arrow, and this is the arrow for precipitation. So whenever we write this BaSO4, we have to show this downward arrow, and this downward arrow represents the precipitate indication. So never forget this downside arrow. What is observed when Na2SO4 reacts with the BaCl2? A white precipitate of barium sulfate is formed. The type of reaction is double displacement reaction and precipitation reaction. What is a precipitate? An insoluble solid formed during a reaction is called a precipitate. White precipitate, BaSO4, ion exchange happens, insoluble solid is formed, type is double displacement reaction. Okay, this is an simple example, and we can see in NCERT that Na2SO4 aqueous plus BaCl2 aqueous gives BaSO4 solid plus 2NaCl aqueous, and this BaSO4 is solid and it is insoluble and it is a precipitate. Here downside arrow is not shown in NCERT, but when we are writing for the exam, you have to show that downside arrow. Also you have to clearly specify the states or whether it is aqueous or solid state, that you have to clearly mention in the exam. And finally we are going to the activity 1.11. This is the last activity in this chemical reaction. Yes, we are going to complete this activity. Oxidation of copper and reduction of copper oxide. What is the activity? Heat a china dish containing about 1 gram copper powder. What do you observe? So in the image we can see a china dish containing copper powder, and a wire gas is there, tripod stand is there, and a burner is there. What we can observe while heating this copper powder? Copper plus oxygen gives copper oxide, black. Okay, and copper oxide plus hydrogen gives copper. Okay. Gain oxygen is an example for oxidation, and lose oxygen is called as reduction. Aim of the activity: to understand oxidation and reduction reactions using copper. Materials required: copper powder, china dish, burner, hydrogen gas setup. Procedure: take copper powder in a china dish, heat it strongly over the flame. Observe the color change. Pass hydrogen gas over heated copper oxide. And this passing of hydrogen gas is not mentioned in the activity 1.11, but while reading we can understand that this is mentioned in the bottom of this activity. So pass hydrogen gas over the heated copper oxide, observe the change again. Here what is the observation? Copper or brown turns black on heating. On passing hydrogen, black substance turns brown again. The step is 2Cu plus O2 gives 2CuO, and this CuO plus H2 gives Cu plus H2O. This copper oxide is black in color. In NCERT you can clearly see that this copper oxide is black in color, and then when this copper oxide is again combined with hydrogen, it again form copper and water, and this copper is brown in color. Always remember that copper is brown in color. Scientific explanation. In step 1, copper gains oxygen, oxidized forms copper oxide. Okay. Here we are saying that copper combines with oxygen. Here copper gets oxygen. So it is called as oxidation reaction. Addition of oxygen is an example for oxidation reaction. Here addition of oxygen is happening, and here we can say that the formation of copper oxide is an example for oxidation reaction. But similarly, addition of hydrogen is an example for reduction reaction, or removal of oxygen is called as reduction reaction. Addition of oxygen is oxidation reaction, and removal of oxygen is reduction reaction. Where what happens in this reaction? CuO, copper oxide removes oxygen, or oxygen is removed from copper oxide and forms copper oxide plus water. So here copper oxide is reduced. In step 1, copper gains oxygen, therefore it is oxidized and forms copper oxide. In steps 2, copper oxide loses oxygen and forms copper, so it is reduced. Hydrogen gains oxygen, so it is oxidized. Here what happens? Hydrogen combines with oxygen and forms water. So we can see in the second reaction we can say that copper oxide is reduced and hydrogen is oxidized, because hydrogen combines with oxygen and forms water. So it is an example for an oxidation reaction. Both oxidation and reduction occurs together is called a redox reaction. Those reactions in which both oxidation and reduction happens is called redox reactions. Oxidation and reduction occur simultaneously in a reaction. That's an example for redox reaction. And type of reaction or concept is oxidation reaction, reduction reaction, and redox reaction. So we can see here we can see a hydrogen gas. Here copper oxide is formed. Here heating copper, then hence copper oxide is formed, and when we pass hydrogen gas through this copper oxide, it combines with the copper oxide and forms copper and water. Copper is brown in color, whereas copper oxide is black in color. Draw copper heating black copper oxide, hydrogen passing brown copper, label oxidation and reduction. Copper powder is heated in air forming black copper oxide. When hydrogen gas is passed over it, copper is obtained again. 2Cu plus O2 gives 2CuO, CuO plus H2 gives Cu plus water. Copper is oxidized in the first reaction and reduced in the second. This is a redox reaction. Keywords for full marks: oxidation, reduction, redox, gain of oxygen, loss of oxygen. Common mistakes to avoid is missing oxidation and reduction, writing wrong color change, forgetting hydrogen role. What is oxidation and reduction? Oxidation is the gain of oxygen, whereas reduction is the loss of oxygen. We can also say in another terms, oxidation is the removal of hydrogen and reduction is the addition of hydrogen. Okay, that we will study in later classes or in another chapter. Identify oxidized and reduced substance. In the first reaction, Cu plus O2 gives CuO. Cu plus 2Cu plus O2 gives 2CuO. We can say that copper is oxidized and CuO is reduced. Sorry, in the first reaction, that is here we can say that copper is oxidized, and in the second reaction copper oxide is reduced because their oxygen is removed. and hydrogen is oxidized. Copper oxidized, CuO reduced, and if here hydrogen is there, hydrogen is oxidized. Why is it a redox reaction? Because both oxidation and reduction happens, hence it is an example for redox reaction. CO converts to CuO, that is, it is a black colored precipitate, and it's an example for oxidation, and CO converts to copper due to reduction. Hydrogen get oxidized. Redox reaction, both together. Here it's ChatGPT saying that we will get a final revision of all the activities and equations in one page. Okay, just we can have a quick revision of all the activities in the chemical reactions. Let's finish strong with a one page final revision. Chapter 1, all activities plus core concept. Final revision sheet. Okay, first activity, we say that zinc plus acid produces what? Everybody opens their textbook and look for the activity 1.1. Okay, in 1.1 we can see that this is an example for 1.3. This activity belongs to 1.3. 1.1 and 1.2 we can see later. Here it is saying the activities from 1.3 to 1.11. Okay, we can just quickly revise these activities and go to 1.1 and 1.3, 1.2. So 1.3, zinc plus acid gives which gas we will get when metals combine with acid? We will get hydrogen gas. So observation was effervescence and a pop sound. Pop sound indicate hydrogen gas. So the gas formed was hydrogen, and type of reaction was displacement and exothermic reaction. What was the equation for this activity? Zn plus H2SO4 or HCl gives ZnSO4 or ZnCl2 plus H2. Here hydrogen is the gas formed because metals when react with acid forms hydrogen gas and salt. It is an example for displacement because zinc displaces sulfate from H2SO4. So it was an example for displacement reaction. Also it is an exothermic reaction because heat was released. Then in 1.4 activity we see that CaO plus H2O, the reaction between calcium oxide and hydrogen oxide, we get calcium hydroxide, that was slaked lime, right? Yes, slaked lime. Quicklime combined with water gives slaked lime. Her observation was heat was formed and a white paste was formed. The paste was calcium hydroxide, and this was an example for a combination reaction plus exothermic reaction. Two substances combined together to form a third substance, calcium hydroxide, and it was an example for combination and exothermic reaction. And FeSO for heating, and 1.5 we said about FeSO for heating. It is an example for thermal decomposition reaction as FeSO4 gets splitted onto Fe2O3 plus SO2 plus SO3, and their green color converted into white color, and white color again converted to brown color due to the formation of Fe2O3. Also there was a pungent smell was formed. Pungent smell was formed due to the formation of gases SO2 and SO3, sulfur dioxide and sulfur trioxide. And 1.6 activity, there also happens thermal decomposition, and PbNO3 twice was thermally decomposed to form 2PbO plus 4NO2 plus oxygen. And The NO2 forms a brown fumes and the color of PbO was yellow, and it was an example for thermal decomposition reaction. And 1.7 we studied about electrolysis of water, where observation was H2 is double, the volume of what H2 formed is double that of oxygen. H2O come 2H2O on decomposition gives 2H2 plus O2, and since 2H2 is formed as compared to 1H2, we say that double the volume of hydrogen is formed. And here we said that anode oxygen is formed, and at cathode hydrogen is formed. That was an example for electrolytic decomposition. And in 1.8 we get AgCl, silver chloride, in the presence of sunlight gives Ag and Cl2. It is an example for photochemical decomposition reaction. The color of AgCl was white and it turns to grey. Grey is the color of silver, that is Ag. And in 1.9 we studied about displacement reaction, where activity of iron is higher than that of copper, and iron displaces copper from copper sulfate solution forming FeSO4. And since blue color fades and forms light greenish color due to the formation of FeSO4. Also iron gets a brown coating of copper. And in 1.10 we studied about double displacement reaction, where Na2SO4 reacts with BaCl2 giving BaSO4 and NaCl. Sodium chloride and barium sulfate was formed, and the barium sulfate was a insoluble white precipitate, and it was an example for double displacement as well as precipitation reaction. And in redox reaction, brown color becomes black and then again brown is formed. What was the reaction? Cu plus O2 gives 2Cu plus O2 gives 2CuO. Copper oxide is formed. Since copper oxide is black in color, and when we pass hydrogen gas to this copper oxide, H2 plus CuO gives, we will get what? Again this copper is formed. Copper plus water is formed. This copper is brown in color. And this reaction, what all happens? Redox reaction means reduction and oxidation happens. So it is an example for redox reaction. As addition of oxygen is oxidation reaction and removal of oxygen is reduction reaction. Whereas addition of hydrogen is reduction reaction and removal of hydrogen is oxidation reaction. So these are the reaction we have studied. We have studied about combination reaction, decomposition reaction. In decomposition reaction we have studied about two types of decomposition reaction. Which are they? Yes, thermal decomposition and photochemical decomposition. And displacement reaction we have studied, double displacement reaction we have studied, and redox reaction, oxidation and reduction together happens. Here combination reaction we can see that A plus B gives AB. Decomposition reaction, AB splits up into or decomposes into A plus B. And displacement reaction we can see A plus BC gives AC plus B. And in double displacement reaction we can see AB plus CD gives, the displacement happens AD plus CB. Most important equations that occurs in from 1.3 to 1.11 is Zn plus 2HCl gives ZnCl2 plus H2. That is metals plus acid gives salt plus hydrogen gas. Metals when reacts with acid forms which gas? Hydrogen. The sound of hydrogen gas is as it forms a pop sound, and it is an example for Zn plus 2HCl gives ZnCl2 plus H2 is an example for displacement reaction. Okay. Then calcium oxide plus H2O gives CaOH twice is an example for combination reaction. CaO is called as quicklime. CaOH twice is called as slaked lime. CaOH twice is which color? White color. Okay. Then next reaction, 2FeSO4 gives Fe2O3 plus SO2 plus SO3. This is an example for thermal decomposition reaction, right? Here the smell of this SO2 and SO3 is pungent smell. Okay. Fe2O3, the color of Fe2O3 is green color. Okay. Next reaction is PbNO3 twice gives 2 PbO plus 4 NO2 plus oxygen. Here the color of NO2 was brown fumes and PbO was yellow precipitate. This is also an example for thermal decomposition reaction. Then electrolytic splitting or electrolytic decomposition of water occurs. 2H2 on decomposition gives 2H2 plus O2. Here 2H2 is formed, hence we call 2H2 is formed, so we called double the volume of oxygen is obtained, and oxygen is formed at anode and hydrogen is formed at cathode. Then 2AgCl gives 2Ag plus Cl2. Here it is an example for decomposition reaction. Which decomposition reaction? Photochemical decomposition reaction. Okay, and here the color of Ag was gray and color of AgCl was white. Then next reaction, Fe plus CuSO4 gives FeSO4 plus copper. This is also an example for displacement reaction. Here which is more reactive, iron or copper? Iron is more reactive, so iron displaces copper from copper sulfate and forms iron sulfate, and this iron sulfate is green in color and copper is brown in color. Na2SO4 plus BaCl2 gives BaSO4 plus 2NaCl. Here BaSO4 is a precipitate, the color of the precipitate is white, and this is an example for double displacement reaction. Okay. Key definitions. Oxidation is gain of oxygen or loss of hydrogen. Reduction is loss of oxygen or gain of hydrogen. Precipitate is insoluble solid formed. Exothermic is heat released and endothermic is heat absorbed. Common board mistakes. Whenever you write the exams or whenever you write the chemical equations in board exam, you have to always write in balanced chemical form. Balanced equation. Writing wrong gas, carbon dioxide instead of hydrogen or NO2, missing keywords, that is effervescence, precipitate, etc. We have to write or indicate the sign of precipitate. What is the sign of precipitate? An inward arrow towards downside. Forgetting the reaction type. Super memory tricks. 4 heat, 5 color, 6 brown gas. What all are they? Metals plus acid gives hydrogen. Sunlight, on the presence of sunlight, AgCl decomposes and form Ag plus Cl. It's an example for photochemical decomposition reaction. And in double displacement reaction, precipitate was formed. What was the reaction? Yeah, precipitate was barium sulfate, right? Yes. Na2SO4 plus BaCl2 gives NaCl plus BaSO4. That was the reaction for double displacement reaction, and their barium sulfate was formed as a precipitate. Last 10-second revision. Gas, hydrogen or NO2 or oxygen. Color green to brown, white to grey. White to grey was formed in the case of which reaction? Photochemical decomposition reaction. What was the reaction? 2AgCl gives Ag plus Cl2. 2AgCl gives 2Ag plus Cl2. That was the reaction for this white to grey color, because white was the color of AgCl, grey was the color of silver. Okay. Color green to brown. Green to brown. What was the reaction? Green to brown occurs in which reaction? Here no, here no, here no. Green to brown. Yes. Fe2O3 was brown in color, right? Yes, this was the reaction. What was the reaction? From green to brown, FeSO4 on heating gives Fe2O3 plus SO2 plus SO3. Here green color was of FeSO4, whereas it first converts to white color and then converts to brown due to the formation of Fe2O3. Heat, exothermic reaction. Which all were the reaction for exothermic reaction? That we can look earlier. and exchange, double displacement reaction. Oxygen gain or loss is redox. Gain of oxygen or addition of oxygen is called oxidation reaction. Removal of oxygen is called reduction reaction. Addition of hydrogen is called reduction reaction. Removal of hydrogen is called oxidation reaction. And the reactions in which both oxidation and reduction happens is called redox reaction. And activity 1.2 and 1.3 needed. Sorry, 1.2 needed. Okay, if you actually mean something else, tells me no. Chemical equation, short representation of a chemical reaction using symbols and formulae. First activity was magnesium plus oxygen gives magnesium oxide, Mg plus O2 gives MgO. The balanced chemical equation is 2Mg plus O2 gives 2MgO. Balanced chemical equation, okay, very important. Number of atoms on LHS is equal to RHS based on law of conservation of mass. And here it is, all our revision, full revision is shown here. Okay, let's ask for activity 1.1 and 1.2 revision. Burning of magnesium. Magnesium burns in air to form magnesium oxide. Magnesium oxide color was white ash. Burns with dazzling white flame. Forms white powder MgO. Equation 2Mg plus O2 gives 2MgO. Type of reaction occurring here is combination reaction and exothermic reaction. Magnesium must be first cleaned to remove oxide layer or remove impurities from the magnesium. Then in 1.2, zinc plus acid gives hydrogen gas. Zinc reacts with acid to produce hydrogen gas. Observation, as effervescence or bubbles were formed, gases burns with the pop sound, test tube becomes warm. Because the reaction was an example for exothermic reaction. Zn plus H2SO gives ZnSO4 plus H2. Type of reaction, displacement reaction, exothermic reaction. Mass combination displacement. Exam ready answer. How do you know a chemical reaction is occurred? Change in color, evolution of gas, change in temperature, formation of a new substance. Okay, whenever the chemical reaction is occurred, we can say that there will be a change in color. We have seen so many examples. Evolution of gas, we can see many examples. There will be change in temperature or formation of a new substance. Then whenever this happens, these four things happens, we can say that a chemical reaction is occurred. First one, color change. Second one, increase or decrease in temperature, that is change in temperature. Third one, a new substance is formed or during the evolution of a gas, we can say that chemical reaction has occurred. Common mistakes, writing MgO as magnesium, no. Forgetting pop sound in 1.2. Pop sound indicates which gas? Hydrogen gas. Not writing balanced equation. In 1.1, white flame is formed, that is magnesium oxide. 1.2, bubbles is formed, that is hydrogen gas. Now we can check which all are the exothermic reaction. From activity 1.1 to 1.11, which all are the exothermic reaction. Burning of magnesium is exothermic reaction. Zinc plus acid was an example for exothermic reaction. Actually 1.2 was lead nitrate solution. We were adding lead nitrate solution to potassium iodide solution and we were forming a displacement reaction. That was the activity 1.2. And 1.3 is an exothermic reaction, and calcium oxide plus water is also a strong exothermic reaction. So only 3 reactions were exothermic reaction. Which were they? First one is burning of magnesium. Second one, zinc plus HCl or H2SO4 gives ZnCl2 or ZnHO4 plus hydrogen, and that is reaction of metals with acid. And third one is example for combination reaction, that is calcium oxide plus H2O gives calcium hydroxide. So these three activities are examples for exothermic reactions. Activity of lead nitrate with potassium iodide. Great, this is a very important activity, yellow precipitate. Okay, this was the example for yellow precipitate formation. When two solutions are mixed, an yellow precipitate is formed. Materials required lead nitrate, PbNO3 twice, and potassium iodide. When we mixed this, a bright yellow precipitate of lead iodide was formed. This precipitate is bright yellow in color. PbNO3 twice plus 2Ka gives PbI2 plus 2KNO3. It is a ballast equation. Scientific explanation: the ions exchange between the solution. Pb2 plus iodine gives PbI2 insoluble solid, and K plus NO3 minus gives KNO3 remains in solution. This was an example for double displacement reaction. And here we can see all these type of colorful images. Board exam we have studied this activity earlier. We are just revising it. So we can see that an yellow precipitate of lead iodide was formed. Now we can just rearrange all the activities. Examples for precipitation reaction. Sodium sulfate plus BaCl2 gives BaSO4 plus 2NaCl. This was an activity we have studied for double displacement reaction. In this barium sulfate, the precipitate is formed. Lead nitrate plus potassium iodide, PbI2, yellow colored precipitate is formed. And silver nitrate, AgCl, AgNO3 plus NaCl gives AgCl plus NaNO3. This is another double displacement reaction. Here AgCl is formed. This is a new reaction, we have never studied that. And CaCl2 plus Na2CO3 gives CaCO3 plus 2NaCl. This is also an example for precipitation reaction. Barium chloride plus sodium carbonate, BaCl2 plus Na2CO3 gives BaCO3 plus 2NaCl. This is also an example for precipitation reaction. From activity 1.1 to 1.11, which all are the precipitation reactions. Precipitation reaction activity 1.1 to 1.1. Activity 1.10, that is Na2SO4 plus BaCl2 gives BaSO4 plus 2NaCl. This is only an example for precipitation reaction. And lead nitrate plus potassium iodide, an yellow precipitate is formed, that is PbI2, is also an example for precipitation reaction. Okay, only two precipitation reactions we have studied. One is the activity, the lead iodide or lead nitrate plus potassium iodide gives lead iodide plus potassium nitrate. Here yellow precipitate of lead iodide is formed, PbI2, And one more example, here we have said that sodium sulfate plus BaCl2 we have studied for double displacement reaction. Here also barium sulfate precipitate is formed. The color of barium sulfate here is white. Insoluble precipitate of barium sulfate is formed. We have studied 3 exothermic reaction. First one is Mg plus O2 2Mg plus O2 gives 2MgO. Then as metals reacting with acid, that is Zn plus 2HCl gives ZnCl2 plus H2. That was also an example for exothermic reaction. And third exothermic reaction we have studied about CaO plus H2O gives CaOH twice. That was an example for exothermic reaction. So we have studied in from the activities 1.1 to 1.11, 11 activities, we have studied 3 exothermic reactions, 2 precipitation reactions. Okay. If you want, I can give you a classification of all activities, combination, decomposition, displacement, redox in one table. Very useful for 5 mark questions. Okay. Okay. But strictly from activities 1.1 to 1.11. There is no such oxidations. Only one precipitation reaction. Sorry, ChatGPT will show errors, but we have considered 2 reactions. That is, first we have said that lead nitrate plus potassium iodide giving lead iodide plus potassium sulfate. Here lead iodide was formed, yellow color precipitate was formed. That was an example for precipitation reaction. And also 10th activity, Na2SO4 plus BaCl2 gives BaSO4 plus 2NaCl. Here white barium sulfate is formed. That is also an example for precipitation reaction. And here activity name and concerned reaction. Burning of magnesium, zinc, calcium oxide, zinc sulfate. All activities reaction is formed. Reaction is specified in this slide. Okay. Burning of magnesium, it is an example for combination reaction. And zinc plus dilute H2SO4 gives ZnSO4 plus H2. It is also example for displacement reaction. And zinc plus H2SO4 gives ZnSO4. Repeat concept. Here it was HCl. Then if it is HCl instead of H2SO4, we can say that ZnCl2 plus hydrogen is formed. Then calcium oxide plus water. It is an example for combination reaction. Also it is an example for exothermic reaction because heat is formed. Here also burning of magnesium, heat is formed, and it is also an example for exothermic reaction as well as combination reaction. Zn plus H2SO4 ZnSO4 plus H2 is an example for displacement reaction. And heating ferrous sulfate, FeSO4 gives Fe2O3 plus SO2 plus SO3, example for thermal decomposition reaction. And lead nitrate decomposition, example for thermal decomposition reaction. Electrolysis of water, that was an example for electrolytic decomposition. Silver chloride in sunlight is example for photochemical decomposition. Iron plus copper sulfate, example for displacement reaction. Sodium sulfate plus barium chloride, example for precipitation reaction as well as double displacement reaction. Copper reactions concerned with the copper is an example for redox reaction. The color of copper oxide is color of copper oxide, it is black, and color of copper is brown. Barium sulfate color is white. FeSO4 color is green. Ag color is white. Sorry, gray. AgCl color is white. PbO. Okay, since our break section start. End of a session. Now we can see after 10 minutes break. So now we can go to important classification. Oh, here we can see that combination reaction, decomposition reaction, displacement reaction, double displacement reaction, exothermic reaction, precipitation reaction, etc. as activity number. No need to study the activity number, but we have to study which all reactions or which all activities belongs to the particular classification. Which one supermemory lines, munitions, and revise this full chapter. I need to revise this. Revise this for like this. MCQ. Magnesium burns in air to form MgO. A. Which activity shows effervescence with pop sound? Whenever I am revising this particular question, you have to give the answers in the chat box. Okay, you have to just specify only the answer for the particular question which I will read. Okay, magnesium burns in air to form A, B, C, D. Magnesium oxide, MgCl2, MgOH2 is MgSO4. Okay, A. Which activity shows effervescence with pop sound? We have to avoid this type of questions because ChatGPT is not that much reliable or accurate. We have just remember which activity leads to the formation of pop sound. Comment in the comment box. For randomly I am giving this as answer B, but you say it in the comment box. Which activity during the formation of pop sound? When pop sound was formed? During the formation of which gas? Yes, hydrogen gas. What was the reaction? Zn plus HCl gives ZnCl2 plus H2. There hydrogen gas was formed. That is, metals when react with acid gives salt plus hydrogen gas, and that hydrogen gas formation leads to the formation of pop sound. Which reaction is strongly exothermic? FeSO for heating, CaO plus H2O. Option C, PbNO3 twice heating. Option D, electrolysis of water. Yes, option number B. Green crystals turning brown on heating is. Oh, like I feel like ChatGPT needs to get through the activity, or it is showing that activity name instead of 1.5, 1.6. Brown fumes are observed in. Right, let's recollect this activity. Avoid asking 1.1, 1.2. As 1.1, 1.2. The names or equation or features. Yes. Activity. So asking activity as 1.1.2, etc. to 1.11. Execution features. So, which reaction produces a gas that burns with pop sound? Yes, now it's some more specific. Calcium oxide plus H2O. No, what was forming in this reaction? First, okay, the answer is B. What is formed in CaO plus H2O? CaOH twice. CaOH twice is also known as, what is that compound called as? Calcium hydroxide, okay, also called slaked lime. CaO is called as quicklime, and that reaction was the example for combination reaction. Okay, and it was an example for strong exothermic reaction. And Zn plus HCl, metal reacts with hydrochloric acid or H2SO4, that is metal react with acid to form salt and hydrogen gas. FeSO4 on heating gives which all product? Fe2O3 plus SO2 plus SO3. The color of FeSO4 was green. Okay, the color formed on Fe2O3 is somewhat brown. AgCl in sunlight gives Ag plus Cl2. Color of AgCl is white. Color of Ag is somewhat grey. Which reaction is strongly exothermic and forms slaked lime? Come on, A, B, C, D. A. Which reaction shows green to brown color change with pungent smell? Which reaction shows green to brown color change with pungent smell? The green to brown color with pungent smell means SO2. The compounds of sulfur is formed. Here FeSO4 heating is Fe2O3 plus SO2 plus SO3. Answer will be B. Which reaction produces brown fumes or nitrogen dioxide gas? You can see from the equation itself, PbNO3 twice on heating gives PbO plus NO2 plus NO2. The reaction will be an example for decomposition reaction, right? Which reaction produces gases in the ratio 2:1? Electrolysis of water. Which reaction is photochemical decomposition reaction? AgCl exposed to sunlight. Which reaction results in blue solution turning green and brown deposit forming? Iron plus copper sulfate. Which reaction forms a white insoluble precipitate barium sulfate? Answer B. Which reaction is an example of double displacement? Na2SO4 plus BaCl2. Which reaction shows oxidation and reduction both occurring? Cu plus O2 gives Cu and Cu plus H2 gives Cu. Which reaction involves loss of oxygen? Let's look for activity 1 to sorry, questions 1 to 10. Okay, all are correct. 11 and 12. 11 and 12 just we can answer. Which reaction involves loss of oxygen? Loss of oxygen. CuO gives copper. It is an example for loss of oxygen. B. And which reaction produces yellow precipitate? Yellow precipitate. Barium sulfate formed is white in color. PbNO3 twice plus Ka gives Pbi plus KNO3. Yes, this Pbi is an example for yellow precipitate. Option B. Give you another MCQ test hard level. Yes. A student observes a reaction where a white solid forms immediately when two solutions are mixed. Which is correct? Decomposition reaction, displacement reaction, double displacement reaction, combination reaction. White solid. Which was the white solid precipitate we have studied in the activity? That was, I think so, barium sulfate. Right? Yeah. That barium sulfate was formed by the activity or the reaction. Sodium, it was example for double displacement reaction, that is sure. For C, what was the reaction? Barium sulfate formation reaction. NaSO4 plus BaCl2 gives NaCl plus BaSO4, right? Yes, that was a reaction. Which reaction involves both oxidation and reduction simultaneously? Here CuO plus H2 gives Cu plus H2O, right? Here CuO is reduced to copper and hydrogen is oxidized to water. So here both oxidation and reduction occur simultaneously. Which statement is correct about electrolysis of water? Oxygen is formed in double amount, right? Hydrogen is formed in double amount. Sorry, oxygen is formed in double amount, that is wrong. Hydrogen is formed in double amount. 2H2O gives 2H2 plus O2 was the reaction. Hence 2H2, since two molecules of hydrogen is formed, it is considered as a double amount. So B. Both gases are equal, no. Only hydrogen is formed, no. B. A reaction produces a gas with pungent smell and color change from green to brown. Identify the reaction type. Whenever pungent smell is formed, it is formed due to SO2 or SO3, and color change occurs from green to brown indicates FeSO4 is converted to Fe2O3, right? That was a reaction. FeSO4 on decomposition gives Fe2O3 plus SO2 plus SO3. That was an example for decomposition reaction. Which reaction is not a decomposition reaction? First one is decomposition reaction. PbNO3 twice decomposes to PbO plus 4NO2 plus oxygen. AgCl decomposition. H2O decomposition. Calcium oxide plus water decomposition reaction. Whenever there will be change in state or evolution of gas, color formation, precipitate formation, etc., we can say that a chemical reaction has occurred. Which reaction shows photochemical decomposition? Exposure of AgCl to sunlight. Which of the following is an endothermic reaction? Endothermic reactions are those reactions in which heat is absorbed. In zinc plus acid, we can see that exothermic reaction because heat is released. Calcium oxide plus H2 is strong exothermic reaction. Heating of FeSO4, here we are heating FeSO4, so heat is absorbed. So C will be the most probable answer. In Fe plus CuSO4, it is an example for slight exothermic reaction. Which reaction produces a yellow precipitate? Na2SO4 plus BaCl2 gives BaSO4 plus NaCl. Here BaSO4 is white precipitate. PbNO3 twice plus Ka gives Pbi. PBI is an example for PBI or PBI2, which was a compound formed. PBI2, right? So what will be the reaction formed there? Okay, lead iodide is PBI. And here we can see that yellow precipitate is formed in case of option B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And which process represent reduction? Reduction. CO converted to copper. Here we can say that copper oxide, removal of oxygen is happening, and it is an example for reduction. Here look, Fe gives Fe2 plus. Whenever in neutral state is converted to an +2 oxidized state, or Fe plus 1 or Fe2 plus or Fe3 plus, it is considered as an oxidation reaction. CO to Cu gives CO on reduction only gives copper. Here oxygen is removed. Which of the following involves both a color change and gas evolution? Here AgCl on Ag plus Cl2, there is also a color change occurring, but Cl2 is not gas. But in FeSO for heating, here Fe2O3 is formed as along with SO2 and SO3. Fe2O3 is brown in color. Green converts to brown. So B will be the answer. Okay. Yes. Now we can look for some of the assertion reason question that is very common in CBSE. Okay. Same for all. A is both A and R are true, and R is correct explanation, and both A and R are true, but R is not correct explanation. A is true, R is false. A is false, R is true. Question 1. Assertion A. Zinc reacts with the dilute acid to produce hydrogen gas. That is true. Zinc is more reactive than hydrogen. Zn plus HCl gives ZnCl2 plus H2. Since zinc is more reactive than hydrogen, it displaces, and it is an example for displacement reaction. Yes, A. Both A and R are true, and R is the correct explanation. Calcium oxide reacts with water to release heat. This is endothermic. No, we said that this is strictly exothermic. So A is true, R is false. C. Silver chloride turns grey in sunlight. True. It decomposes into silver and chlorine. Yes, that's why it appears grey in color. A. Both A and R are true, and A is the correct explanation of R. Iron displaces copper from copper sulfate solution. Right. Iron is less reactive than copper. No, iron is more reactive than copper. That's why iron displaces copper from copper sulfate solution. A. Electrolysis of water produces hydrogen and oxygen gases. True. Hydrogen is collected in double the volume of oxygen. True. But is it the correct explanation? We cannot say that it is the correct explanation. Both A and R are true. So we can give this as B. Lead nitrate produces brown fumes on heating. Lead nitrate produces brown fumes. PbNO3 twice on heating is PbO plus NO2, right? It produces brown fumes. I have a little doubt about that activity. Is it right? Nitrogen dioxide gas is formed. That is true. I think both A and R are true, but R is not the correct explanation. B. Barium sulfate is formed as a precipitate. True. It is soluble in water. No. Whichever is insoluble in water is called as a precipitate. So A is true, R is false. C. Oxidation is gain of oxygen. Correct. Reduction is loss of oxygen. True. Both A and R are true, but not the correct explanation. B. Decomposition reaction requires energy. True. Because in both photochemical decomposition reaction, thermochemical decomposition reaction, either temperature or light is needed. So it requires energy. Bonds are broken during decomposition. That is true. Since bonds are broken during decomposition, it gets split into its compounds using energy. Since it will be both A and R are true, and R is the correct explanation of A. You give it as like that. Copper oxide is reduced to copper when hydrogen is passed over it. Copper oxide is reduced to copper. Yes. Copper oxide gains oxygen. Copper oxide gains oxygen. No, copper oxide is losing oxygen and forming copper. So R is false. A is true, R is false. C. You can look for the answers. Okay, question number 4. Iron displaces copper. Iron is less reactive. False. A is more reactive. What is the answer? C. We have also given that C na. Your answer A. 4. I have given us A. Oh, that was a mistake. Iron is more reactive than instead of A. 2, 3, 4, 5, 6, 7, 8, 10. 4 I have to give that C. Then B. Water displaces to water to oxygen. H2 is double. But R explains why. It is not explanation. Correct B. We have also given us B. Okay, here it is something mistake. Only 4 is wrong. Our B is correct. Since water, that is correct. That's a minute mistake from ChatGPT. And question 6, brown fumes is formed. Nitrogen dioxide gas is formed. R explains A. Correct A. 6. Question number 6. Lead nitrate produces brown fumes on heating. Nitrogen dioxide gas is formed. Since nitrogen dioxide gas is formed, brown fumes are formed. Yes, right. Okay. The color of nitrogen dioxide is brown color. So since NO2 is formed, it appears as brown color. So we can say that it is the correct explanation of A. So I got 2 wrong answers. This one and this one. This was mistaken, and this was a silly mistake. That was option C was the correct answer, but I marked as A. I know the correct answer, but question number 6 I made a mistake that I am correcting it. But question number 5, it was right. It is a mistake from ChatGPT side. Okay. Final mixed MCQ assertion plus case study. Okay. Which reaction produces hydrogen gas with pop sound? Which is a reaction? Zn plus HCl gives ZnCl2 plus H2B. Which reaction is endothermic? FS of heating. Which gas causes brown fumes? NO2. Hydrogen pop zone. Which is a double displacement reaction? NaCl plus BaCl2 gives NaCl plus BaSO4. C. Which reaction is photochemical? AgCl in sunlight. Okay, assertion reason type. Iron displaces copper from copper sulfate solution. True. Iron is more reactive than copper. A. Silver chloride turns grey in sunlight. It decomposes into silver and chlorine. A. Electrolysis of water produces hydrogen and oxygen. Oxygen is produced in double amount. A is true, R is false. C. A student performs the following experiment. This is case study. A student performs the following experiment. Adds barium chloride solution to sodium sulfate solution. Observe formation of a white solid. What is the white solid formed? Barium sulfate. Identify the type of reaction. Double displacement. Which is the solid form? Why is the solid form? Because it is insoluble, hence it is called as a precipitate. Yes! Made full answers correct. What this means? Concepts are excellent, application excellent, board pattern full ready. You are not just prepared, you are exam ready at topper level. Revise equations once daily. Remember keywords: effervescence, precipitate, exothermic. Always write reaction type in answers. Okay. Expected 3 to 5 mark answers, having very high probability. Okay. Let's look at questions. What are the characters of a chemical reactions? Okay, the characters of a chemical reactions are: first one, color change, then increasing or decreasing of temperature, that is change in temperature, then it should undergo evolution of gas, whether it forms a formation of precipitate, change in state, that all are examples for chemical reaction. It's evolution of gas, change in temperature, change in color, formation of precipitate, change in state, and formation of precipitate. What is a balanced chemical equation? Why is it important? This all we will study later. A balanced chemical equation is one in which the number of atoms of each element is equal on both sides. It is important because it follows the law of conservation of mass. It gives correct information about the reaction. Explain the types of chemical reaction with examples. The main chemical reaction we have studied is combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. In combination reaction we have studied about Mg, 2Mg plus O2 gives 2MgO, and CaO plus H2O gives CaOH twice plus heat. That all are examples for combination reaction. And for decomposition reaction we have studied about thermal decomposition reaction and photochemical decomposition reaction. Thermal decomposition reaction we have studied about Fe2SO4 on heating gives Fe2O3 plus SO2 plus SO3. Also we have studied about PbNO3 twice on heating gives PbO plus NO2 plus oxygen. And for photochemical decomposition reaction we have studied about AgCl, decomposition of AgCl. AgCl on decomposition gives AgCl2 plus AgCl on decomposition gives Ag plus Cl2. And for displacement reaction we have studied about Fe plus Zn, Fe plus CuSO4 gives FeSO4 plus Cu, since iron is more reactive than copper. And for double displacement reaction we have studied about Na2SO4 plus BaCl2 gives BaSO4 plus NaCl, and this BaSO4 is white precipitate. Combination reactions, we can say that two substances combined together to produce one single product. That is combination reaction. Decomposition reaction, one compound breaks into two or more simple substances. And displacement reaction, one element replaces or displaces the another element it is called a displacement reaction. And double displacement reaction, exchange of ions occurs between the compounds. When exchange of ions occurs between the compounds, it is called as an example for double displacement reactions. What is a precipitation reaction? Give an example. What is a precipitate? Precipitate is insoluble. It is not soluble in water. It is solid. Those reactions in which a precipitate that is insoluble, water insoluble, solid substance is formed. That reactions are called precipitation reactions. Example is Na2SO4 plus BaCl2 gives BaSO4 plus NaCl. A precipitation reaction is a reaction in which an insoluble solid, that is precipitate, is formed. Explain oxidation and reduction with example. What is oxidation reaction? Addition of oxygen is oxidation reaction, or removal of hydrogen is oxidation reaction. And what is reduction? Removal of oxygen is reduction reaction. Also, addition of hydrogen is reduction reaction. Example was, for oxidation reaction is Cu plus O2 gives 2Cu plus O2 gives 2Cu. That is an example for oxidation reaction. And what is an example for a reduction reaction? Reduction reaction, for both oxidation and reduction reaction. That means those reactions in which oxidation and reduction happen simultaneously is called a redox reaction. They are asking for a redox reaction. The redox reaction example is CuO plus H2 gives Cu plus H2O. Here CuO is reduced and H2 is oxidized. Why should a magnesium ribbon be cleaned before burning? To remove the oxide layer formed on the magnesium, or to remove the dust. There can be two reasons. The two reasons are valid answers. Magnesium ribbon is cleaned to remove oxide layer on its surface so that it burns properly. Why is respiration considered as an exothermic reaction? That all we will study later. Respiration is an exothermic because glucose reacts with oxygen to release energy. C6H12O6 plus O2 gives CO2 plus H2O plus energy. Why are decomposition reaction opposite of combination reactions? Because in combination reaction, two or more substances combine to form a single product. Whereas in decomposition reaction, that one single product or a single compound is decomposed or split into two or more components. Hence, they are opposite in nature. What is corrosion? This all we will study later. What is rancidity? We will study later. Very short 2-mark answer. Specifically from the activities. Study. You want very short 2-mark answers from activities only. Exactly what comes in exams. 2-mark rapid revision. Activities are 1.1, 2.1. What is observed when magnesium burns in air? What is observed when magnesium burns in air? Yes, magnesium burns with a dazzling white flame and forms white ash. What happens when zinc reacts with a dilute acid? We have to first think about the reaction. Zn plus HCl or Zn plus HCl gives ZnCl2 plus H2. Right? Hydrogen is formed, that is true, because metals react with acid forms hydrogen plus salt. Whether it is ZnCl2 or ZnCl, that is a doubt. That is that we can look earlier. And there hydrogen forms with a pop sound. What is observed when calcium oxide reacts with water? It is an example for strong exothermic reaction. CaO plus water gives calcium hydroxide plus heat. That CaO is called quicklime and calcium hydroxide is called Slackline. What happens when ferrous sulfate is heated? When ferrous sulfate is heated, FeSO4 is heated, that forms Fe2O3 plus SO2 plus SO3. Here Fe2O3 is brown in color and FeSO4 was white in color. Green in color. Green crystals turn white and then brown, and gases with a pungent smell are evolved. Since SO2 and SO3 are formed, that will give a pungent smell. What is observed when lead nitrate is heated? Lead nitrate decomposes to lead oxide, that is yellow residue, and NO2. NO2 is brown fumes. What happens during electrolysis of water? Water decomposes into hydrogen and oxygen gases in the ratio 2:1. What happens when silver chloride is exposed to sunlight? AgCl on exposure to sunlight gives Ag plus 2Ag plus Cl2. Ag is grey in color. What happens when an iron nail is dipped in copper sulfate solution? Fe plus CuSO4 gives FeSO4 plus Cu. Iron displaces copper from copper sulfate solution because iron is more reactive than copper. That is an example for displacement reaction. Also, what happens when an iron nail is dipped? Also, what happens to iron nail? Iron nail gets a brown coating of copper. What is observed when Na2SO4 reacts with BaCl2? White precipitate of barium sulfate is formed. What happens when copper is heated in air? Copper is heated in air to form copper oxide, and this copper oxide color is black in color. What happens when hydrogen is passed over copper oxide? Redox reaction occurs. Copper again is formed. Copper is brown in color, and also H2O is formed. Black copper oxide turns brown copper as it gets reduced. How to score full marks? Always include observation, scientific word, effervescence, precipitate, etc. Next we can try some 1-mark questions, 1-word questions, specifically from activities. Gas evolved when zinc reacts with acid. It is hydrogen. Sound produced by hydrogen gas. Pop. Product formed when calcium oxide reacts with water. Calcium hydroxide. Color of ferrous sulfate crystals. Green. Gas with a pungent smell in FeSO4 heating is sulfur dioxide. Brown fumes gas from PbNO3 to is nitrogen dioxide. Ratio of gases in electrolysis of water 2:1. Gas collected in double mode hydrogen. Color change of AgCl in sunlight grey. Metal deposited on iron nail is copper. Color change of copper sulfate solution blue to green. White precipitate formed in Na2SO4 plus BaCl2 barium sulfate. Types of reaction precipitation. Double displacement reaction. Color of copper oxide is black. Process of gain of oxygen is oxidation. Fill in the blanks. Okay. Specifically from activities, these and wait for my reply. Magnesium burns in air to form Mg plus O2 gives MgO. Magnesium oxide MgO. Zinc reacts with the dilute acid to produce hydrogen. The gas that burns with pop sound is hydrogen. Calcium oxide reacts with water to form calcium hydroxide. It is also called slaked lime. Quicklime, what is the formula of quicklime? Calcium oxide. Ferrous sulfate crystals change from green to dash color on heating. Green to brown color due to formation of Fe2O3. Lead heating lead nitrate produces dash colored fumes, brown colored fumes, as due to the formation of NO2. The gas responsible for brown fumes is NO2. During electrolysis of water, the dashed gas is produced in double amount, hydrogen. Silver chloride turns dash in sunlight, grey in sunlight. Iron displaces dash from copper sulfate. Iron displaces copper. The blue color of copper sulfate solution changes to light green due to formation of this is asking about the reaction between iron and copper sulfate, and we can say that copper sulfate, the blue color of copper sulfate changes to green colored FeSO4 solution. Dash precipitate is formed when Na2SO4 reacts with the barium chloride, barium sulfate. The precipitate formed is barium sulfate. Copper turns dash when heated in air. Cu plus O2 gives CuO, that is black in color due to the formation of copper oxide. Passing hydrogen over copper oxide converts it into copper and water. Copper. Okay, in fifth question, it is asking that ferrous sulfate crystal change from green to white, then brown. Okay, we have to specify that first it will get converted to white and then it will converted to brown, because as ferrous sulfate crystals means it should have dot 7H2O. So first heating removes this water and this ferrous sulfate gets converted to white, and then this ferrous sulfate gets converted to Fe2O3 and then therefore brown color occurs. And in 12 and 13, there was the 13 is correct, barium sulfate. 12 is also correct, barium sulfate is the form, but the ChatGPT asked for white precipitate. The dash precipitate is formed when Na2SO4 reacts with BaSO2. They asked about color, but I gave about BaSO4. I thought about the formula they were asking for. Okay, that is also correct, and 13 also correct. It's okay. Ask type or appearance, therefore it white precipitate. Question 30 asks for name. So I write about barium sulfate. I gave them the molecular formula, but they asked for the full name. Color, write color. Name, write full name. Observation, write properly. So whenever the board exams are asking, you can write the full name of the compound and in bracket you can give their molecular formula. That will be better. Match the following. Okay. Column A, column B. Oof. Burning of magnesium. Burning of magnesium, brown fumes, no. White precipitate, no. Hydrogen gas with pop sound, white ash, MgO is formed, E. Then zinc plus dilute acid, hydrogen is produced, na. Hydrogen gas with pop sound is produced, C. Calcium oxide plus water, calcium oxide plus water, calcium hydroxide, white ash, MgO, heat released and cycle lime is produced, I. Heating ferrous sulfate. Heating ferrous sulfate, we will get green to white and white to brown color change, F. And for heating lead nitrate solution, we get brown fumes of NO2 gas. And electrolysis of water, electrolysis of water, hydrogen and oxygen in the ratio 2:1. Silver chloride in sunlight, grey color due to silver formation. Iron plus copper sulfate, iron plus copper sulfate. Blue color turns green, copper deposited. Sodium sulfate plus barium chloride, white precipitate, barium sulfate is formed, white precipitate. Copper plus oxygen, copper plus oxygen, copper plus oxygen. It is an example for copper oxide is formed, black color precipitate is formed, black copper oxide is formed, D. Yes. So I think the activity section is somewhat fully studied in this section. And now it's the turn to study about the exercises from this chapter. So I can give 2-minute final revision sheet. No. Now it's the time to study about the exercises from this chapter. We can look for the exercise answers. Give me the descriptive explanation for exercise. Section from first chapter. Okay. Perfect. This is the way to prepare for boards. One question at a time with deep understanding. Let's start with exercise question 1, chapter 1, chemical reactions and equations. Which of the statements about the reaction below are incorrect? Two PbO plus carbon gives 2 Pb plus CO2. Lead is getting reduced, carbon dioxide is getting oxidized, carbon is getting oxidized. First, let's look for the option A. Option A, lead is getting reduced. Lead, no. By looking the question, we can say that what happens to PBO? PBO converts to PB. We said that what happens to PBO? Oxygen is removed. Whenever oxygen is removed, it is an example for reduction reaction. So PBO is reduced is right. That is, lead oxide is getting reduced is right. So it is not the answer, because in question it is asked for incorrect answer. And what happens to carbon? Carbon combines with oxygen to form carbon dioxide. Therefore, carbon is oxidized because addition of oxygen happens. So, carbon is getting oxidized is also right. Then these two questions. Lead is getting Lead is getting reduced. No, lead oxide is getting reduced. Carbon dioxide is getting oxidized. Carbon dioxide is also not getting oxidized. So, what will be the correct answer? PBO, lead oxide becomes lead, carbon becomes carbon dioxide. Oxidation, gain of oxygen, reduction, loss of oxygen. PBO loses oxygen, hence becomes PB. So PBO is reduced. And check carbon, carbon is getting oxidized. Lead is getting reduced. Carbon dioxide is getting, so there were two incorrect answers, A and B. So incorrect statements are both A and B. Why this question is important? Test oxidation and reduction clarity. Common confusion element with compound. Gain oxygen, loss oxygen. Ready for question number 2. So it is clear now? It is very simple. Addition of oxygen is oxidation. Reduction of oxygen or removal of oxygen is reduction reaction. Addition of hydrogen is reduction reaction, and removal of hydrogen is oxidation reaction. In this reaction we can see that carbon combines with oxygen to form carbon dioxide. So oxygen is added to carbon, hence carbon is oxidized. In PBO, PBO converts to PB. That is, removal of oxygen happens from PBO. So PBO is the compound that is reduced. PBO is lead oxide. So lead oxide is reduced. Then coming to the question number 2. Okay. The above reaction is an example for Fe2O3 plus 2Al gives Al2O3 plus Fe. Is a combination reaction? No, because combination reaction, what happens? A plus B gives AB. Here two reactants combine together to give more than one product. So it is not a combination reaction. Double displacement reaction? No, because here is only one element and there is no such displacement occurs. And decomposition reaction? No, because in decomposition we need some kind of heat or energy. Also, single product or single compound gets decomposed into multiple simple components. Here it is not like that, so it will be the reaction for displacement reaction. And always remember that aluminum is more reactive than iron. So aluminum displaces iron from Fe2O3 and aluminum oxide is formed and iron gets free. So this reaction is an example for, I think it will be the example for displacement reaction. Observe the reaction. Iron oxide Fe2O3 reacts with aluminum. Aluminum removes iron from its compound. Products formed is Al2O3 plus iron. Identify what is happening. Aluminum is more reactive than iron. So aluminum displaces iron from iron oxide. Yes. In iron and copper, which is more reactive? Iron. Yes. In iron and aluminum, which is more reactive? Aluminum. So aluminum greater than iron greater than copper. Okay. Remember in that way. Aluminum greater than iron greater than copper. Their reactivity. Match with the reaction types. Combination reaction. Two substances combine together to form one product. Not happening here. Decomposition reaction. One substance splits into many. Not happening here. And in double displacement reaction, exchange of ions between compounds, note here, displacement reaction, one element replaces another, aluminum replaces iron. Important concept. The reaction is also known as thermite reaction. Okay, this reaction, that is Fe2O3 plus aluminum gives Al2O3 plus iron. This reaction is called thermite reaction. Thermite reaction, and this reaction is used in welding railway tracks, and it produces a lot of heat. So it is an example for exothermic reaction. Also, this reaction or this concept is used for welding railway tracks. That's important. And the reaction is also called thermite reaction. Why it is called thermite reaction? Because in the term itself it is showing that this thermite or thermometer, it's all related with temperature, heat, etc. So a lot of heat is produced in this reaction, hence it is called as thermite reaction. Final answer, displacement reaction. Extra understanding, aluminum is oxidized, iron oxide is reduced, so it is also a redox reaction. More so it is a break section. Today we have studied total 2 sessions, total 100 minutes we have completed. We have completed the total activities. Also, we have revised the full activities. Now we are studying the exercise section, and after completing this exercise section we will go to the small exercise section that is given in the textbook now. That is exercise 1.1 in between small boxes in the textbook, that we will study, and after that we will go to the previous year questions, and after covering all this we will again study this chapter from start to end, and there our full concept will be okay, and we can write any questions that will come in the board exam. Okay, today we are signing off.